Welcome to another episode of my ongoing series about programming in Hopper, the Hopper language. And it's a bit of a focus on how Hopper differs from the other semicolon and curly brace languages. So I'm assuming that you have familiarity, hopefully, with one of the modern curly brace languages like C# or Java, but C or C++ will also do. This little episode is about reference types and the reference argument. Let's get on with it. That's how you define a list of strings in Hopper. And we're going to use our local method to append to our list. So we're going to pass the list in. We're going to append a few items to it, and then we're going to go for each item in the list. We're going to print out the item like that. So as an argument to our method, we're going to pass in, so this is our list argument, and in here we're going to append to it. So let's think about how references work. So this list here is a variable here declared in the main method. When it comes in here, list arg is exactly the same variable, because it's passed, reference types are passed by a reference to the original. So this should work as you expect it to see, as you see on the screen. So let's try it. Compile it and run it. So we get 4 items as we expected. Right. So that's how reference types work. And reference types include strings, dictionaries, lists, and arrays. There's a little bit more to it than that, but that's enough for now. Strings, unfortunately, are a little bit hinky, and we have C# and Java to blame for that. Because in Java and C#, strings are immutable, meaning once you create a string, it can never be changed. It'll always have that value. And it's an optimization they made. So they intern strings in one big chunk somewhere, and they take advantage of that. If I had strayed from this behavior, it would have made it very difficult, very confusing for people who are familiar with C#. So you'd expect that you do something similar to a list like that, right? So if we try and compile that, it tells me that a function cannot be used as a method, and you already know what this means if you've watched the other videos. It means that append is a function, which means it must be returning a value, because it can't modify the string. It returns a new string, right? So we can go and have a look at it inside the string unit, and there's append, which is a system method, and it returns a value. So it takes the string, appends this one here, appends a string to it, and then returns a new string. Okay? So the value inside str_arg when it enters this method is a reference to this str here. What am I going to do with the return value, return result? You'd think you just do that, right? But it doesn't do what you think it does, because what it's done is it's changed the value of the reference str_arg locally. It hasn't touched this. It was passed a reference. It now refers to a new reference. It never goes back out the method. So if we build this and then we run it, we have nothing, no content, because str was never modified. It passed in a reference to itself. That reference got changed to a different reference but never got returned. So we could solve this a number of ways. We could return this value. So one way to do that is to make this have a return value, and then you go return the value, and now we need to do this everywhere. So on every step here, str changes to a new string, and that works. We end up with item, 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 item. But there's another way to do it too. So let's use the other way. And the other way to do it is to pass this in as a reference. So we're passing in the actual original reference as opposed to making a copy of the reference, a local copy of the reference to the original. So this will achieve the same thing as the return value did. There we go, item, 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 item. So a little bit tricky to get your head around as to what a reference really is. So if you just passed it in without the ref keyword, it actually made a copy of the reference, which means when we assign something into it, we were modifying the copy of the reference, not modifying the original reference. By passing it in as a reference argument, we're now modifying the original reference when we do this copy. And the way this also supports this, the word copy there is kind of key. This is a garbage collected managed memory management system, just like Java or C#. So to make that work, it does reference counting, but it also does a deep copy on assignment. So if you copy a reference type like this, it actually makes a new copy of something. It doesn't override the original, and so, or doesn't keep the original there. So if you copied a dictionary like this with an assignment statement, or you copied a list, it would do a deep copy of the entire dictionary to a new reference. So it makes a copy on assignment. Okay, so interesting references and the reference argument. So now there's something else about the reference argument too. But this is more convention than it is built into the language. So assume we have a string like that and we want to convert it to an integer I. If we were in C, we'd have a to I and we'd do that, right? But the problem with a to I, and many methods like it in C, is that they overload the return value with error values. So for example, if you try and open a file that doesn't exist, you get back a null file handle. So they overload the file handle with an error. In this case, if you passed in Bob, you'd get 0 back. So you wouldn't be able to tell the difference between actual valid 0 value and Bob. So the convention we use to solve this is something we also inherited from C# or Java, which is the idea of a TryParse method. And so we'll pass in our integer to TryParse, but the return value is a success or failure. So it's true for success. So, and then we pass in a second value for the return result. So if we failed, it would return false. So that not gets us here on a failure. So we go error. And if we succeeded, we want to print the value of I. Right. And this TryParse, like I said, it's convention. It's not part of the language. So I have a TryParse method that exists inside the compiler. So if I just include some source code from the compiler, we can use it like that. So if I go look in here, it probably has a whole bunch of TryParse methods. TryParse for a long, which takes a long return value, int, integer return value, and then success or failure is the Boolean return value for that. So that's the one we're going to use, right? So let's compile that, and let's run it. So yeah, we get 10 back. And then if we make it into Bob again, we get an error back, as we expect. So we've learned about reference types, we've learned about returning multiple values from a function, and that'll be enough for now. Thank you for watching.